Hi guys, this video is on reaction quotients, and this basically explains how we interpret this particular piece of information. What we do is we use the reaction quotient, or Q, when the system is not at equilibrium, and we are looking for trying to find which direction the reaction is shifting. Is it shifting back to the products? Is it shifting back to the reactants? What's going on? And what we do is we actually are going to plug in our initial concentrations. Now we only use this to compare to K. So you've already found the reaction at equilibrium. Often they'll ask you to then analyze the reaction not at equilibrium. So I wrote down an equilibrium expression that you've seen from yesterday, and it's basically reactants over products raised to their exponents, okay? But this time we are going to use the initial concentrations, okay? And it's simple algebra at this point, but we want to really compare what we get from what Q becomes versus what K is, and that's going to tell us a lot of information. Okay, so when we compare Q to K, let's say you've done your algebra. I'm not going to do the algebra for you. You guys are bright and can do that. What I am going to compare in this case is when Q and K don't quite meet, okay, or when they do meet, what that means for the system itself. So what is going on in that container at that time? So if Q is equal to K, okay, the system is at equilibrium. Okay, so the system is equilibrium, everybody's happy and dandy, which that makes sense. So I said we don't use Q. We don't use Q to do any direct analysis, but we use Q as a comparison between K. So if K and Q are the same, then the system is at equilibrium. Okay, kind of weird. If Q is greater than K, okay, so if Q is greater than K, what that means is that the products, okay, the concentration of those products, okay, are larger than the reactants. And what that means, if I can write quickly, hopefully you can read my handwriting, that means that the equation shifts to the left. Okay, it's going to end up shifting to the left. Now we read top to bottom, left to right, so that means that the products actually break down. We're going to use up the products and make more reactants. Okay, so we're actually going to shift back to the reactants, and that does happen. That's actually a very common situation. The other situation we can have is when Q is less than K. Okay, in this case, the concentration of the reactants is larger, or is larger than the products. Sorry for my handwriting. It's the concentration of the products. And that means that the reaction is going to shift to the right. Okay. So this is just one more piece of analysis to determine what is really going on in that system at that time. Okay, and that's where the real money points are. Okay, and we'll talk more about this on Thursday. I just wanted to introduce it to you so you can kind of play with it. Okay, good luck with that.